In this video, we're going to take all the rules we did in the semantics video, our syntactic structure, we're going to combine them and do a tree for an entire sentence. So when these are typed out, these look very neat. When you do them by hand, they can look quite ugly because things get messy, you don't give yourself enough space, and all that stuff. So I'm going to show you one that's typed. I'm going to do one by hand. It's going to look a little bit messy. It's going to be the reality of things. And then, yeah, we'll go through this. So the sentence we're looking at, it is not the case that Sophia likes James. So first we draw a syntactic structure for it, and then we can put all of our meanings in that structure, or we can write them in a list beside it. So we don't have to do this on our semantic tree itself if we don't want to, but it's nice to do it when you start just because you can see all the pieces coming together. When we do quantified truth later by hand, we will not be doing everything on the tree at once because it just gets quite messy. This is also, and I'll be completely honest, this is also where online teaching just does not work great with this. In class, we can have 4 blackboards with a tree up and we can do everything piece by piece and make it all nice and keep everything up. With a screen of this size, we cannot keep everything up at once. So I can't keep all the information on screen at the same time. I'm sorry. It's just the unfortunate reality of being in this situation. So it is not the case that Sophia likes James. We first draw our syntactic structure. I won't put in the terminal nodes, but our structure would be something like this. So we have, it is not the case that, and then we have our sentence, Sophia likes James. So it is not the case that goes under negation. We have Sophia, our subject. We have likes, which is our transitive verb. And we have James, which is our object noun. So this is the same structure on the right. What I've done too here, though, is I've given things labels. So because we have 2 nouns and 2 sentence nodes, I gave them indices so that way we can differentiate them. S1 is our smallest sentence, S2 is our bigger one, N1 is our subject, N2 is our object. You can pick whatever indices you want. They don't have to be in this order. But it's just to separate them if we were to write it out in list notation. So I'm going to zoom in and we'll take a look at these piece by piece. So we start out with our lowest nodes. So I do the object first, and this is James. We introduce James, we need to get the value of James. So we can call this James prime or J prime. It is up to you. If I handwrite, I usually just use the first letter to save time. So the meaning of any proper name or the value of any proper name is just that name with a prime symbol beside it. Now it goes up to the noun node. So James is a noun. So the noun gets its meaning from its daughter. It only has one daughter here, so the rule is that it just has the same meaning as the daughter. So that's the rule. We write the rule when we have rules. Then its value is James prime. So we make sure that every non-terminal node, we have both a rule and a value. We just need those 2 lines. So at this point, well, we can't build up any further because the VP value depends on the value of the transitive verb and the object noun. So first we have to do likes. So let's do likes. Well, likes is a transitive verb, which means we're looking for subjects and objects. These are pairs of things where the subject likes the object. So we say a pair of xy such that x likes y, and because we're always in some situation v, we make sure that in v is listed in there. So we know we're talking about in the situation that's true. Now, the transitive verb only has one daughter, so it gets its meaning from its daughter. So we write a rule here. The rule is that the value of the transitive verb gets its meaning from its daughter. And it has the same value. So the set of xy such that x likes y and v. We have no modification here, no changes. At this point, we can move up to the VP. Now, the VP, remember, this is essentially the phrase likes James. So what should the meaning of that be? Well, we should be looking for all the things, all the subjects that like James. So that's what we have here. We have a rule in line 1, which says we're now looking for singletons. We're now looking for x, such that our subject is x, and the object, we know what the object is. It's the value of n2. And this is in the set for likes. So I have an intermediary rule here, or intermediary step, that just shows us what this is. So now I'm looking for x, such that pairs with x James are in likes. In other words, this means that James is always the object in this case. I'm looking for all of the things that have pairs with James as the object. So the value is this final step here. So we really just need lines 1 and line 3. Or paraphrase, I'm now looking for the set of X, our subjects, such that X likes James prime in V. That's the meaning of our verb phrase. Okay, at this point, we now need to find the meaning of the sentence. So that's the sentence, Sophia likes James. So before we do that, we need to know the meaning of Sophia. So Sophia, we're going to call this Sophia prime, or we could call this S prime if we're writing it by hand. It goes up to the noun. It has just one daughter, so the value of the daughter, the rule for the daughter is just going to be, take the same meaning as the daughter, and that'll give us a value of Sophia prime. Okay, at this point, now we go to the sentence level. And sentences are propositions. They have truth values. So we can say that a sentence is true if and only if the subject noun is an element of our verb phrase set. So Sophia likes James will be true if Sophia is in the set of X such that X likes James in V. Okay, so if Sophia is in the set, then the sentence is true. If Sophia is not in the set, then the sentence will be false. So our first line has the rule, and our second line has the value. Now, building it up, remember the sentence was negated. It is not the case that Sophia likes James was our sentence. So now we have to deal with it is not the case. Now, this should be a little triangle here, but I did not write that in LaTeX, but that's okay. A line or a triangle doesn't really matter to me. There's more than one word in there, though, so it should be a triangle. It is not the case that. This is a function, truth value. So it takes 1s to 0s, and it takes 0s to 1s. That is what this one does. So we write that in matrix form. That's how we do all of our connectives. Going up to the negation, it only has one daughter. It is not the case that. So the rule is that it takes the value of the daughter, which, there we go, is the same matrix. So then, when we go up to the final node for the sentence, it is not the case that Sophia likes James. What we do is we take our negation and we apply it to the sentence. So our original sentence said that it is true if and only if Sophia is an element of that set. So the negation flips the value. So now we know it's false if Sophia is an element of the set. Now we can stop there, or we can paraphrase. Instead of talking about when it's false, we could also talk about when it's true. So in that case, it would be true if and only if Sophia is not an element of the set of X, such that X likes James in V. Either of those values would be fine. So at the end of our tree, here's what we have. This is our final tree. So all of our little notes are here. I can just get rid of these so we can see what the final tree looks like. But this is an entire compositional semantic tree for the sentence. It is not the case that Sophia likes James. And it tells us when our sentence is true or when our sentence is false. Now, this is for any generic situation, but we can have specific situations. So imagine we have a specific situation V1 where it is the case that Sophia likes James. So we can ask ourselves then, is this sentence, is 16 true or false? Well, this says it is not the case that Sophia likes James. So it's false if Sophia is in the set of X such that X likes James. But our situation V1 says that Sophia does in fact like James. So this sentence comes out to be false. So this is really just the same thing as truth tables. If P is 1, 0, then not P is 0, 1. It's the same idea, but instead of using propositions, we're now using entire sentences. So we have an example question here, and I'm going to just do 17 by hand. If you want to do 18 and try it yourself, you can. But we need to draw sentences for these entire semantic composition trees, and then evaluate situations. So this is going to take some time. It's going to take up a lot of space. It's going to be a little bit messy, but we can do it. And the reason I'm doing this sentence is for a few reasons. One, this has a negation in it. It has a conjunction in it. It has a transitive verb in it. It has an intransitive verb in it. And it has nouns in it. Everything that we have in our system is in this sentence. So we're going to see everything here. That's why I'm doing this question. 18 is the same thing, but because we're dealing with an ambiguous sentence, we're just negating something different. So I'm doing the more challenging one in my opinion, but I guess we'll see when you try it. So I already have the skeleton of this sentence written out, and I'm going to do some typing here. I'll do some typing and I'll do some marks, just because otherwise things will get quite messy quite quickly. So we're going to start on the right. You is hungry. So is hungry is an intransitive verb. We can treat it as an intransitive verb. Really, it's a copula is with an adjective hungry. It's a predicate adjective, but we treat it as an intransitive verb. So the meaning of this is going to be a set of people. It's going to be a set that contains things, so X, such that X is hungry in that situation B. So that's going to be the meaning of is hungry. We're looking for all the people that are hungry. Now, we go up to the intransitive verb, and the meaning of the intransitive verb is just going to give us the same value as the meaning of is hungry. So that's our rule. It's going to have the same value as is hungry. So we can actually just copy and paste this up to save us some time. In fact, if you're using a computer, I recommend this. Save as much time as you can by copying and pasting things. But it only has one daughter, so it takes the same value. It's going to be the same with the VP up here. So the VP only has one daughter. It has the VI. So the value of the VP is going to be the same as the value of the intransitive verb. And remember, we write it again because we need a rule in each line and our value. So instead of X, I said X is hungry in V. That's going to be the same meaning as the VP. Okay. Let's do the value of U now, our subject of this sentence. So U, we'll call this Y prime. So that we're just saying that Y prime is our person U in the world, and we can draw him like this. So Y prime just represents this person. Now let's call this noun 1, and let's call this VP1 actually, because we have multiple VPs and multiple nouns in the sentence. So the value of our noun is going to be the same as the value of U, because it has just one daughter. So that's our rule, and this means Y prime is the value of our noun. So at this point, we can go up to our first sentence, S1, and we can ask ourselves, when is this sentence true? Well, the rule says for sentences that it's going to be true if and only if the value of our subject is an element of the value of our verb phrase. So basically what this means is that our subject is in the set of things, whatever our verb phrase is. So Y prime should be in the set of X such that X is hungry. So we can type this out. So this is going to be 1 if and only if Y prime is an element of, I'll put the symbol in there after, X such that X is hungry in V. So that is going to be the meaning of our first sentence on the right. U is hungry is true if U is in the set of X such that X is hungry in V. Okay, that's our first one. Let's now go to U dislikes Carol. So same sort of idea. I'm going to do U and Carol first just to get them out of the way. So the value of U is going to be Y prime as we said before. Let's call this N2 and N3. Let's call this VP2, and this verb is transitive. Okay, so the value of N2 is going to be the same as the value of U. We write our rule out and we write our value. Carol, what are we going to call Carol? Well, let's call her C prime. The value of the noun 3 is going to be the same thing as the value of Carol, since it has just one daughter, which is Carol, so the meaning passes up, so that's C prime. Now, dislikes. Okay, we need to get the meaning of dislikes. Well, dislikes is a transitive verb. It needs a subject and it needs an object. So what we're looking at here is we're looking at a set containing pairs x and y. So these are pairs of x, y, such that x dislikes y in our situation v. So that is the meaning of dislikes. We're looking for pairs xy such that x dislikes y and v. In this case, x is our subject and y is our object. So the meaning of the transitive verb is going to have the same meaning as dislikes because dislikes is its only daughter, so that's our rule. And then we can copy the value here. So the meaning of the transitive verb is going to be the set of xy such that x dislikes y and v. Now, when we go up to the meaning of our VP, transitive verbs have a rule. So now we have our direct object, so we're just looking for subjects. So we're looking for subjects, x, such that the pair of x and our direct object are in our transitive verb. So what this means, and we'll have to do some movement here, so we can get it out of or. In fact, maybe it's just easier to move or up here a little bit. Okay, that's a little bit better. It's actually still not ideal, so maybe we can do a little bit more movement. We're moving a little bit too much. That's okay. Like I said, this is going to be a little messy when we do this, just because there's so much stuff and it's so easy to run out of space on the page. That would go here, and that goes there. Then we'll make this line go down here. Okay. So we're looking for subjects x, where we have pairs x and our object in the set of dislikes. So I can now type this out. I'm not going to write out the second line that I normally do because we don't have to, but now we're looking for the set of x such that x dislikes c prime in v. So we're looking for the set of people that dislike Carol. That's what we're looking for now. So that's our meaning, that's our value of our verb phrase. So now when we go up to the sentence here, let's call this sentence number 2. In fact, let's just move this over to the right. I want to move everything. Put that there, put that there. Sure. There we go, and let's move that to connect right there. Okay. So the value of this sentence, this is going to be true if and only if our subject noun is an element of our verb phrase here. So we can paraphrase this and we can plug in some values. So this is going to be true if and only if y prime is going to be an element of our set of x such that x dislikes Carol in our situation. So the meaning of the sentence U dislikes Carol, that sentence is true if U is in the set of x such that x dislikes Carol. So doing it piece by piece, these things make sense. It's when we take a step back and we look at the entire thing at once that things get kind of scary. But if we just do this piece by piece, we can get through this. So at this point, we have our 2 sub-sentences here. Now we have U dislikes Carol done and U is hungry done. Now we have to do the conjunction, which is going to take both of these together. In fact, I'm going to move these up as well so we can have a little bit more space to draw out or. So or is a connective. Let's do this in blue. Why not? Or is a connective. So this is going to be a matrix that takes pairs of truth values and assigns them to a truth value. So we have 1, 1, 1, 0, 0, 1, and 0, 0. So or is true if either of those are 1. So it's going to be true in the first 3 situations and false in the last. So when we get the meaning of our conjunction, according to the rule, this is going to be the same thing as the meaning of or, which is just going to be the same as this matrix right here. So we can copy and paste that right there. I'll make it a little bit smaller just so it doesn't take up so much room. Now, let's take a look at the meaning of our third sentence here. When is this going to be true? Well, we need to apply a rule first. Now this has 3 daughters. It has a conjunction and 2 sentences. So what we do is we apply the conjunction to our sentences. So we take a conjunction and we give it two inputs. We give S2 as our first input, and we give S1 as our second input. So when is this true? This is going to be true if and only if S2 is true or S1 is true. So this compound sentence will be true if you dislikes Carol or you is hungry. So at this point, all we really do is we just substitute in our values. So I'm actually just going to type this one out because it'll save us a little bit of time and make it a little bit neater. So this is going to be true if and only if U is in the set of X such that X dislikes Carol in V, or U is an element of the set such that X is hungry in V. So I'll put in the element symbols. In fact, I'll make this all fit on one line. And we'll just take some of these bars and we'll move them out of the way to make space. Okay. So, intuitively, when is you dislikes Carol or you is hungry true? Well, it's true if you dislikes Carol or you is hungry. That's the same thing as saying that you is in the set of people who dislike Carol or you is in the set of people who are hungry. And that's what we have here in our final value. Okay, our last thing that we have to do is we have to negate this. So let's get cracking on that. So it is not the case that this is a function that takes trues to zeros and zeros to trues. So 1 to 0 or 0 to 1. The value of the negation is going to be the same thing as the value of it is not the case that. I'm going to shorthand that, which will also be a matrix from 1 to 0 and 0 to 1. Okay, so finally, for the last step, our final value. This sentence, what's our rule? Well, we take the negation and we apply it to our sentence. So let me move the mic so it's not being hit. So we're going to take the negation, we're going to apply it to sentence 3. And what we're going to get is that sentence 4, we'll call it our complete sentence. This will be true if and only if sentence 3 is false. So when does that happen? Well, I'm going to take this final line here. I'm going to get rid of a couple things that were accidentally copied over. So instead of this being 1, if y is an element of the set of x such that x dislikes Carol in V, or y is an element of the set of x such that x is hungry in V, this is now going to be false in that case. And that is going to be the end of our tree. Now we could write when it's true, and we could use De Morgan's law to do this. So if we have not P or Q, this would be equivalent to saying not P and not Q. That's a Q, not a G. So we could say it's true if y is not an element of the set of x such that x dislikes C, and y is not an element of the set of x such that x is hungry. We could paraphrase it like that. Either way is fine. So that is it as far as the tree goes. We can now zoom out and take a look at it in all of its beauty. When you do these, turn your paper sideways and give yourself enough space. It's a lot easier, I think, to write in pencil and give yourself room than to write in the marker. I can only go so thin on the program. If I could go much thinner, I'm sure this would look a lot nicer. But for the most part, when I give you solutions, I try to type the trees out. So there are 2 practice questions on Canvas in the lecture that have trees typed out. It is not the case that Solomon likes David. And what is the other sentence that I have? I have another tree for Charlie likes Martha, and it is not the case that Fido is brown. And I have those both written out in LaTeX, all nice and neat. So one thing I want to show you is that you can do this in list notation as well. So on Canvas, you see all these things written out in lists. So you can just do a tree and you can label your nodes, and then you can just write out the value of the nodes with the rule and then the meaning beside it. So you can do it in list format if you find that nicer. You don't have to, that is totally up to you. But I will use that method later in the course when the trees get even muddier than this. So we don't have much written here, but when we get to predicate logic and trees with quantifiers, things get quite muddy. And it is really, and I repeat, it is really unfortunate that we don't have an in-class way to do this, because I could have 4 boards filled with information and you could see everything at once and things could be nice and spread out. Unfortunately, we're stuck with something that's a little bit more messy like this. Anyways, we do have one more thing to do, which is to talk about truth conditions. So this is basically just propositional logic with words. So it is not the case that you dislikes Carol or you is hungry. So we can translate this as not, let's say, not C or H. Now the fact in situation V1 is we have C and we have H. So both of these are true. In fact, actually, let's just write this out. C, H, V1, V2, V3. In situation 1, they're both true. In situation 2, you likes Carol, you is hungry. So hungry is true, but dislikes Carol's false. And in the third situation, you likes Carol, that's false, you is not hungry, that's false. And basically it's asking, which situations are true. So we need not C or H. So in the first situation, this is false, because we need not C or H, but we have C and H. V2, this is also false, because we shouldn't have you disliking Carol, and we shouldn't have you being hungry, but we have you being hungry. And in the last situation, it's true, because you likes Carol, you is not hungry, therefore it's not true that you dislikes Carol or you is hungry. So we can look at this in terms of our semantics tree, or we can just convert these into propositional logic and work with it like that. I think going into logic is a lot easier to look at it. With quantified true sentences later in the course, it might be a little bit more difficult. But anyway, that's it for this video. This is our tree. Hopefully, if you didn't quite get it the first time, what I recommend doing is do this tree again by yourself. Go through it step by step, reference the rules, reference the semantics of F1 at every single step, and try to understand intuitively why this works. So I say things like we're just looking for subjects now, because that's what the rule represents. We need transitive verbs, needs a subject and a direct object. That's why we have pairs X, Y. Sentences. Sentences are propositions. Propositions have truth values. That's why sentences are true or false. When we have sentences with conjunctions or negations, we're always comparing things. We're changing truth values. That's why we're applying these connectives, applying these functions to sentences. So if you have any questions, and I'm sure there will be questions, email me, post on the discussion board, and I'll get back to you when I can.